Stretches of functions. A stretch is a transformation that changes the size and shape of the graph. The original and the new graph are not congruent. There are two types of stretches, vertical and horizontal. Vertical is the ones that you guys would have had already. Horizontal are the new ones. So vertical stretches are in the form y equals a f of x. So you guys had this before, right? You always had to find your a value when you had quadratics. And you'd set up your quadratic, and then you'd look for a point, and you'd plug it in for x and y, and you'd solve for the a. That's what you did in quadratic last year. You maybe don't remember that. But you solve for that a, that vertical stretch. Okay? The point then becomes ay, x, ay. So remember, when we had a vertical translation, we went y plus k, or y minus k. We agree? When we had a vertical reflection or reflection in the x-axis, we went negative y. We agree? So if we have a vertical stretch, we are just going to go whatever it is, y. You multiply them. So reflections and stretches multiply, and translations add or subtract, right? So if we had all of them, we would end up having negative ay plus k, technically, which is substantially more crazy than if we just add something or multiply by -1, right? That's why I said mapping is important to follow along, because once we have them all together, it gets a little crazy. Okay. So the points on the x-axis are invariant. Why would the points on the x-axis be invariant? They were invariant when I just had a reflection. If I just have a stretch, the x-axis points are invariant. Why would that be? Yeah, but what are the points on the x-axis? Yeah. Right, y equals 0. And what am I doing? I'm keeping my x's and I'm multiplying my y's by a number, correct? But on the x-axis, my y's are 0. And when I multiply them by anything, what are they going to stay? 0. So they're going to remain invariant because you're multiplying a number by 0. Yeah, it is amazing. Thank you. Okay. If the a has a negative sign in front of it, that's a reflection. You're not going to say vertical stretch by a factor of -3. Your vertical stretches and horizontal stretches will never be negative. They're always just the number. The negative actually is a reflection. Remember that from yesterday? So if you ever had a diploma answer that had a vertical stretch by negative something or horizontal stretch by negative something, you could cross them off. So describe the transformations that occurred if the original graph of y equals -4 f of x was this. So this is the original. This is the new. We always have to go in the order cert. Stretches, reflections, translations. And the reason why, we have to write them in the order stretches, reflections, translations, but when we apply them, we could apply the stretches and reflections at the same time technically because they're both multiplying, right? One's multiplying by a negative, one's multiplying by a number. But we have to do the translations last when we do our operations anyways, always, because it's addition and subtraction. And all we're doing really is we're following order of operations. We're doing multiplication first, then addition and subtraction next, right? So that's why we have to do it in the order cert. When we write them out, they want them in the order cert as well. SRT. All right. It'll be fast. Okay. So we have a stretch here. Because it's in front, it's not in the bracket, right? So it's going to affect the y always. So it's a vertical stretch by a factor of 4 about the, what do you think? X-axis or y-axis? Remember when it affected the y for reflection, what was it about? The x-axis, right? If I'm stretching vertically, I'm going to stretch it about the x. I'm either going to stretch it more or I'm going to squish it, right? It's about the x as well. So the great thing is if it's about the x-axis for reflections or stretches, when it's with the y, at least it doesn't change, right? At least it's not about one and then the other, and that would be super confusing. And then you notice I didn't put -4, right? I just put 4. And then we have a reflection, what? On the x-axis because it's with the y. When it's with the y, it's always with the x-axis. Because if it's with the y reflecting, if it's up here in 1 or 2, it's now going to be in 3 or 4, right? So when it was a reflection, all of our positive y's became negative, all of our negative y's became positive, right? When it's a stretch, if it's a 2, what do you think we're going to do? A stretch of 2. It's going to make everything what? All my y's double. Yeah? So it's going to make it stretch this way, correct? Now let me show you something first. So, oh, where's my calculator? It was on the other one, wasn't it? It went away. Okay. So if I just put the original graph as, let's say, x plus 1. I'm just going to put it in brackets just to prove that the plus 1 is with the x. So I'm just going to do a basic x plus 1, and I'm just saying the plus 1 is with the x. Or we could go x plus 1 squared, let's say. Okay? So that's my basic graph. Now say I vertically stretch it by a factor of 2. It's going to go in front. It's not going to go with the x, right? So it's going to be 2x plus 1 squared. What do you think is going to happen to my graph? Do you think it's going to get wider or narrower? What? More narrow? I didn't hear what you said. Your hand totally heard you. That's good. So it's going to become more narrow. Why? It's a big number. You're multiplying by 2. Why wouldn't it get wider? Because it's going up faster. You're taking those points that are at 1, 1, let's say, or wherever they are, and you're now pulling them to 1, 2, right? So the graph was normally like this at this point, right? Say we were here, yeah? At that same x, our y is going up faster. So now it's here because I'm multiplying that y by 2. Do you agree? So it's really pulling the graph up faster is what it's doing. So actually, if your vertical stretch is greater than 1, your graph is going to be narrower. If your vertical stretch is between 0 and 1, your graph is going to be wider because if you had a value of 2, you're now going to have a value of 1 if it's a half, because a half is divided by 2, right? So it's going to make it wider. Now, why did I go 0 to 1 and then greater than 1? Technically not 0 and not 1. It would be between 0 and 1 and then greater than 1. Why didn't I say negative numbers first off? Can you have a negative vertical stretch? What does the negative do? Reflect. So I didn't say that. And second off, if I put 0, if you put a 0 in front of an entire function, what's going to happen? It won't exist. It's going to go away. If you have a 1, all of them have a 1 originally. Like this one here. Oh, put down marker. This one here has a 1 in front of it. So a 1 has no stretch, right? Okay. Yep. Yep. Okay. So this is my original graph, y equals f of x. I could label it. And then we want 2f of x. So what are we going to do? We're moving coordinates. We're moving a graph. What are we going to do? Yes, we shall. Mapping. So we have x, y. It's going to become x, what? 2y. And I know it's saying x because in my bracket here, I just have an x sitting by itself. And unless it's in the bracket, it doesn't affect the x, right? So if I start with my first coordinate is negative 2, 0. So I have negative 2, 0. It's going to become negative 2 and 2 times 0, which is negative 2, 0. Weird, it stays the same. Why is it invariant? It's on the x-axis, my y values are 0. So indirectly, then, this is also going to be invariant. We agree? Then let's pick this one. Negative 1, 2 is going to become negative 1, and then 2 times negative 2. 2 times 2, sorry, I don't know why I said negative. So it's going to be negative 1 and 4. Oops. And then this one's 1, 2, 3, 4, 5, 0, and 5, so it's going to become 0 and 10. Okay? Now, I could just do that one in my head because it literally just had a stretch on just the y. Do you think that they're possibly going to give you just a vertical stretch on a function on the diploma? Probably not. So that's why mapping is so important. Okay, graph y equals x squared, then replace y with 3y. So y equals x squared is at 0, 0, 1, 1, negative 1, 1, 2, 4. Remember, you could go to your table of values if you wanted to and pull that off your calculator. Or you could just plug in the values. So 0 squared is 0, 1 squared is 1, negative 1 squared is 1, 2 squared is 4, negative 2 squared is 4, and that's how I get my point. This is my y equals x squared graph. It's not drawn very well. It's kind of pointy and weird. Just imagine it's nicer. Okay. Now we're replacing the y with 3y. So we're going to have 3y equals x squared. What do I always want to do? Get y by itself. So how do I get rid of that 3? Dividing by 3 or multiplying by what? 1/3. So I get y equals 1/3 x squared. Now remember that the squared is just to the x currently, right? Like it's like this. So if you want to put brackets there so you know it's a vertical stretch, not a horizontal, please do. Now remind me tomorrow to come back to this, because when we do horizontal, I have to come back to this specific question, because we're not going to finish it today. Just remind me, because it can be a horizontal stretch as well, because it's the squared, but I'll explain that to you later. So we have a vertical stretch by a factor of 1/3 about the what? What's my mapping? X, y becomes x, comma. So we could fill every original point in and get our new, right? Because these are way less complicated, we can literally just keep our x's and third our y's, which makes it a bit complicated. Because this is a 4. A third of 4 is 4 times a third, which is 4/3, which is, yeah. It's now down here. 1 times 4/3, sorry, 1 times 1/3, where do I get 4/3? 1 times 1/3 is a third. Okay, 3, 3, 3, 3, 3. 1/3 times 0. So this is my invariant point. And this is going to be at a third. This is going to be at. It got wider. Why did it get wider? Technically, can I draw these and these arms, like just keep going? Yes. Are they going to be super accurate? No, because it's going to be 9, so it's actually going to cut through 3 on the next one. That'll be here. And then who knows? 4. Okay. So graph y equals square root x and replace the y with 1/2 y. So y equals square root x. We could figure it out, or we could type into our calculator. Either way is fine. If you wanted to figure it out, never gonna happen. Oh, if you wanted to figure it out, you could plug 0 in, and square root of 0 is 0. Plug 1 in, square root of 1 is 1. Plug 4 in, square root of 4 is 2. Right? Because that's all you're doing the whole time. That's all this calculator is doing for you, square root x. Why is there no x's over here? Why is there no graph over here? Right, you can't take the square root of a -1 or -2, -3, -4, -5, so those don't exist. Square root of 0 is 0, square root of 1 is 1, square root of 4 is 2, square root of 9 is 3. Those are the ones I pick. You can pick other ones in between, but they're obviously going to be decimals because square root of 2 is a decimal, square root of 3 is a decimal, right? And errors here because you can't take square root of negatives. So if we went to go sketch that one, we would go 0, 0, 1, 1, 4, 2, 9, 3. I always label so that I know which one is actually which, because you're going to end up with two graphs on, right? And then who knows which one's which. You always label your graphs. Okay, I'm replacing y with 1/2 y. So I'm going to have 1/2 y equals square root x. So to get rid of a third, or a 3, we multiplied by a third. To get rid of a half, we're going to multiply by what? Both sides by? And we have to come back to this example again, too, because I can actually force this to be a horizontal tomorrow as well. It only works with square roots and squareds, which makes sense for. So what do we have here? Vertical stretch by a factor of 2 about the what axis? And my mapping is now going to be xy becomes what? X2y. So all my x's stay the same, my y can multiply by 2. So invariant, which we knew was going to happen. X is 1, y becomes 2. X is 4, y was 2, so it becomes 4. X is 9, y was 3, so it's going to become 6. Okay, I'm going to give you the vertical stretch questions for homework.